Welcome, everybody. My name is Semida Silveira, and I'm professor at KTH and the Royal Institute of Technology, and I will be leading this panel discussion right now. We will have a very brief discussion, unfortunately, due to the time constraint. So we have rescheduled. But here with me, I have Professor Molina, Professor Nakicenovic, Dr. Pachauri, and Professor Bengtsson. Yeah, I'm not going to introduce because I think you have the biographies, and then we save some time. I also want to welcome those who are with us somewhere at home or in some part of the world, because this has been streamlined. And for those who want to ask questions and are far away, you can Twitter, and we will receive the questions here. So the topic of our discussion is our changing climate and how can we balance energy demand with sustainability. Well, I think that's a good question to start with, and I will turn to the panel and ask, can we actually, and if so, how, combine sustainability with actually the increasing demand that we have on energy? So please.
Yeah, first we should recognize that the amount of carbon dioxide we are emitting is equal to about 1,000 tons per second. In addition, we have a lot of other greenhouse gases, but carbon dioxide stands for about 60% of it. So that is really the problem. What we are not, of course, sure about is what the climate effect will be. And since the first prediction or estimate was done by Giuliani in 1979, he gave an interval of from 1.5 to 4 degrees, which was based upon some simple experiments done at the time. Now, the latest IPCC report hasn't changed that very much. So I think maybe we can say that we have confirmed that we don't know exactly the answer. That is very important, because it's probably a system which is not fully predictable because of the internal properties of the system. So that is essentially a political question. Should we prepare for the worst or hope for the best? I think this is the issue. And so far, the warming has been relatively modest, but we have absolutely no guarantee that this is going to continue.
So we may be having here skeptical. Well, let me see what the other panelists.
Well, I think the evidence, in my view, is very clear. As I presented during lunchtime in the recent Working Group 1 report, we have said very clearly that the last 3 decades have been successively warmer than the previous ones. We have also said that since the middle of the last century, clearly human action is responsible for climate change. And I would beg to differ, sir, that it's been relatively modest. If you look at the extreme events that are taking place, which, may I say, have been very clearly assessed by the IPCC, accepted by all the governments, and based on observations, we know that, for instance, heat waves are on the increase, extreme precipitation events are on the increase, and what's more, there's also, at least in some parts of the world, clear evidence linking the increase in the intensity and frequency of storms. This is not uniform across the globe. I fully accept that. And therefore, if you look at projections of the future, if you're talking about a 4-degree increase, then you're really talking about a change in the geography of this planet. And we cannot possibly afford to take that kind of risk, because there are several parts of the world and several communities that would be so adversely affected that you would not even be able to calculate the economic impact of those effects. Now, the good news is that you can do a substantial amount on a win-win basis. If you look at efficiency improvements, you'll take the case of buildings. Professor Stephen Chu very rightly pointed out, this is an area where in the 4th assessment report of the IPCC, we had shown the potential for emissions reductions in buildings. This is an area where you can bring about a substantial change. We have a large number of people who are outside the modern energy system and are currently using biomass or very poor forms of lighting based on fossil fuels. I think there are substantial opportunities over there for moving directly to renewable and decentralized forms. So if you give me another minute, I'll give you an example of what my own institute is doing. We are setting up microgrids using entrepreneurs in villages. Just to give you some numbers, a microgrid for serving 20 households, giving them very clean, basic lighting and a little bit of power to run an improved cook stove, costs 80,000 rupees. You can take the units for whatever they're worth. People are paying 5 rupees a day for this service that they're getting. This amounts to 36,000 rupees a year for those 20 households, which means the payback from this investment is less than 2.5 years. So it's really a question of bringing finance together, creating entrepreneurial capacity, providing the technological inputs that are necessary, and I think there are just substantial opportunities by which we can arrive at win-win solutions. But there are other speakers, so I don't want to hog their time.
So in other words, you believe it's possible to combine the sustainability and actually a stringent
Absolutely,
scenario.
absolutely. And I think you minimize the risks of the impacts of climate change. At the same time, you also bring about a substantial amount of co-benefits and improve the lives and livelihoods of people living in buildings in Stockholm, in this country, Sweden. I think you've done a substantial amount in improving energy efficiency in your buildings. I don't think it's cost a lot of money. And similarly, you can do that throughout the world. I'm just giving buildings as one example, but every sector of the economy has opportunities for improvements at literally negative cost.
Nakicenovic, this is a bit different than what we have heard of some of the scenarios this morning about still, let's say, at least 75% fossil fuels, which then would mean no compatibility. So.
Yeah, I would argue that's different from many of those conventional extrapolation of current trends into the future, but it's not different from scenarios that envisage major transformational change. So let me just try to follow up the argument that Pachi has started. I think sustainability is both about development and about climate. Climate is the major planetary challenge, no doubt for me, but development is also a major planetary challenge. And so we have to find ways to have the co-benefits of resolving both issues at the same time. I think that's definitely possible. The counterexample is we have on the order of 2.5 to 3 billion people who do not have access to modern energy, have to cook with solid fuels. We estimate that maybe up to 4 million people, mainly women and children, die prematurely from that. That's more than malaria. So it's not just a development issue, it's a health issue as well. Now, we will have probably another 2 billion people by the middle of the century. So if you add 3 and 2 on the order of 5, we cannot do that with business as usual. There is no doubt. We would double the emissions, double everything. For me, that's beyond the conceivable. That means that, in my view, we need to decarbonize. And the scenarios show if we want to go in the direction of 2 degrees, and we have a relatively good confidence in what needs to be done. Emissions need to decline by 1/3 to 2/3 by the middle of the century. For that, we need really radical innovations. Efficiency, yes. I would say end use is important, but also on the supply. And let me just, I know we have little time, let me just, in conclusion, express a real concern. I have a very serious concern, and that is we've been working on this for 30, 40 years, how to achieve this transformation, certainly since the first energy crisis in '73, and we are really far behind. And so the really bad news, in my view, is if you look at the literature of these transformational pathways that lead us to 2 degrees and bring the co-benefits that Pachi was talking about, those kind of scenarios usually overshoot our target. They don't approach the target from below, which means we are over-emitting, and then we have to remove the carbon. And frankly speaking, I don't have the confidence that we can do this unless we have experiments and deployment that really shows. I just come from Japan on the conference of so-called negative emissions. I mean, just the word is already bad. Negative emissions. It indicates that there is something bad about it. But I think this is one of our challenges. We don't have much time to lose, but the opportunities are huge of having co-benefits for both climate and development.
Just a second. I want to ask Professor Molina for comments on this compatibility between sustainability and climate change mitigation.
Okay, sure. First of all, the bottom line is that I think it is quite feasible to have sustainable development and satisfying the energy needs of society. But it is no doubt a huge challenge. I certainly agree. I won't repeat what we just heard. I agree with what we heard from Pachi and from Naki. But well, just to give the concrete example, just to make sure we understand what sustainable is, we have inherited from the past some unsustainable practices. The fisheries in the oceans, we know that there are huge problems. So that already happened. We're already working unsustainably. But we know how to solve that, and it's been solved, not everywhere, unfortunately, but in parts of the world. So the solution is at hand. Now, in terms of climate change, I think the very important point here I want to make, perhaps differing a little bit from our first speaker, is that one attitude would be to say, we don't know, because the climate system is complex and so on. And by the way, specifically, that's one worry I have. It's been used also with extreme events. If you look carefully, some scientists are very conservative, say, we just don't know. We shouldn't talk about that. I have a very different opinion. One thing is to say, I don't know, let's do nothing. And I gave an example earlier, but I'll repeat it. I go to my physician because I have a tumor. He looks at it and says, I don't know. Come back in 20 years, we'll see. No, we know a lot. Medicine is there, you can do things. We certainly know if you smoke, what's the probability. So we know a great deal. It's not true that we don't know. Be quiet, because we have evidence-based physics. We know the basic physics behind that. And we have measurements. We know what's happening. But, of course, things are uncertain. But what we know, you have to couple then with economic studies, with social studies, is that the bulk of the problems with climate change will be negative. Not everything. Maybe there will be some parts or northern latitudes that will improve their agriculture. But as climate change has more impacts, it will be damaging everywhere. And we do have examples. So what I know is we certainly have enough evidence to make it a very clear risk. That we know for sure. And that's what should compel society to respond. We don't need certainty. We don't even need to have the most likely or very likely event, like the IPCC, of course, says we have 95% probability that these things are happening. We don't need 95% certainty for insurance. Otherwise, who the hell will insure their house against a fire unless they think there's a 95% probability that it will catch on fire? It's nonsense, okay? So there is a huge probability, very large probability in that context of how society functions, that we're in big trouble. And the big trouble is that the economy has externalities. It's just a huge market failure. These externalities have not been incorporated into the economy. That's why we had sessions here talking about what will fossil fuel energy do in 10, 20 years. Well, you need two very different scenarios. One, where the world will come together and they put a price one way or the other. And then you have a very different scenario for how fossil fuels will compete with each other than if nothing happens, which is what's happening right now. Well, I shouldn't exaggerate. Something is happening. I mentioned California and Mexico and other places. They do have taxes, but it has to be global. And that I agree with Naki. We're very far from doing that. So we need to act
Yeah.
very responsibly and very soon.
So
Uh,
we
no,
don't need full
that was not-
certainty to act.
Yeah,
Do you have
if I can just comment. What I was trying to say was certainly not to question the climate warming. This what I said. I simply said that we have to realize that this is a problem where we only can provide a probability distribution. Now, we are a bit inconsistent in that respect, namely that we are agreeing that we have a probability distribution of the climate sensitivity, which incidentally doesn't agree exactly with the empirical climate sensitivity, incidentally. But when it comes to the identifying level of degree, we are talking about 2 degrees. This is inconsistent because we don't know exactly which amount of carbon dioxide or greenhouse gas forcing which will give us 2-degree warming. And therefore, I think that is, of course, a lack of inaccuracy which goes in both directions, of course. Right. I mean, but we still have this problem that we have emitted now the equivalent greenhouse gas forcing is about 3 watts per square meter, very close to that. And that is actually about almost 80% of a doubling of CO2, in the tropic equivalent CO2. And of course, we still have had a rather modest warming, fortunately, I would say. I think we shall recognize that, and that shouldn't in any way remove the seriousness of the problem, because the sensitivity can very well change. Of course, we know that from model integration.
Just very briefly. Well,
Yeah.
go ahead.
Okay.
Very briefly. It's one of the problems is to focus on just the temperature change. We worry much more about the impacts, the extreme events. Even if the temperature were to change very little, that's not the most relevant.
Yeah, but
Well,
this has been an
let me say
attitude.
this. Let
Yeah.
me say this.
Yeah.
If you look at the record, since the beginning of last century and up to 2010, sea level rise has been 19 centimeters. That's almost close to a foot. Now we can say sitting over here in Gothenburg, it doesn't bother us. Look
3
at
millimeters per year, yeah.
Look at the people who are living in the small island states. They don't have to wait to get submerged. Every time there's a storm surge, every time there's a serious weather event, it's that much more severe simply because the sea level is much higher. You know, in 1997, when I was elected as vice chair of the IPCC, the plenary session of the IPCC was held in the Maldives Islands. And the then President Gayoom, addressed us. He said, ladies and gentlemen, the place where you're meeting today, 6 years ago, was under 1.5 feet of water. So, you know, let's think about what we are doing to certain communities all over the world. And I think just looking at temperature increase is not enough. I mean, there's now a record that since 1993, sea level rise has accelerated. And where is this going to take us? We have projected that if we remain at the upper end of the RCP scenarios, then by the end of the century, we're going to get 98 centimeters of sea level rise. Now, we were talking about probabilities and taking investment, making investment decisions, and so on. I'd like to ask every company that invests in a new project, they are happy to do it if there's a 60% chance of their getting success. Now here we're talking about something where there's a 95% probability that we're affecting the climate. Why aren't we willing to take action to control the situation? So, you know, my submission is that yes, temperature increase is certainly one indicator, but look at all the other impacts. I mean, take a simple thing like sea level rise. 19 centimeters, to my mind, is a very serious increase in this vast body of water that you have on this planet. Look at the melting of Arctic sea ice. Is there any dispute about that? It's observed. There is data by satellites and every other means. And we've projected that by the middle of this century, September Arctic sea ice is likely to vanish. So when you go to the Arctic region in September in 2050, possibly you'll see no ice on the ocean at all. And that has major implications because that's going to change the salinity gradient, that's going to change currents. Quite apart from that, everything associated with marine life and biodiversity in that region is going to change.
Okay, Naki.
Yeah, I wanted to raise another issue in this context, and that is that the problem is very asymmetric. I think this is the most unfortunate part about it. Even if you assume that climate sensitivity is symmetrically distributed, the problem itself is not. I'll just give you an example. Going back to the 2-degree stabilization in scenarios, we know, and that was just published in the Working Group 1 of IPCC that is consistent with the literature, we know that if you want to stabilize at 2 degrees, at the 50% likelihood, we cannot emit much more than another 300 billion tons of carbon, not that order. That's about half of what we have emitted since the beginning of the Industrial Revolution. Now, assume that the climate is not so sensitive and we can emit another 100. That's great, because we're already late. But if the climate is more sensitive, we'll be too late on the pathway, because technology takes time, investment takes time, and I think this is really, in some ways, a very nasty feature of the problem, that we have to make the decisions now without exactly knowing how sensitive the climate is. But if it turns out to be very sensitive, then our precautionary strategy would fail.
Sure.
But if we share that view, we have to do something about the carbon dioxide we have in the atmosphere now.
Yes.
And we have to really implement some very serious sequestration.
Sure.
And this is something where too little is being done at the moment.
I agree.
And I think that should be...
More resources.
Yeah.
Yes.
But that, I think, since we cannot avoid continued use of fossil energy, which I think all agree, it takes a very long time, sequestration will be absolutely essential.
And I would say we start with natural means of sequestration. This planet needs much more green cover. And I think if we were to bring about afforestation in degraded lands, which is scientifically possible, it could make an enormous difference. It gives you a jump start. It gives you time by which you might be able to develop other means for sequestration.
This is a big question, but I'd like, before we break, to have a few questions from the audience. And here I have one, and I have a second one here, and a third one. They are from Twitter, and then we take 2 from Twitter. Yeah, please. Well, please take the microphone and introduce yourself.
I'm Sanne Nusselder. I'm studying industrial ecology at Chalmers University here in Sweden, in Gothenburg. And I have a question. What do you think about BECCS, or bioenergy capture and storage, as a solution or a solution if we start too late with our changing technologies?
Okay.
Enormous potential.
Yeah, but I think with BECCS you refer to the bioenergy together with carbon capture and storage, or just bioenergy alone?
No, the capture of carbon in burning biofuels.
You know, we had a little bit of that discussion in the previous panel. The issue is that we still don't have commercial carbon capture and storage. And bioenergy is also associated with a number of problems. So this is a technology that there is no doubt. I think first comes afforestation, I would agree with that. But second, or in parallel, that technology needs to be developed. But here we are, I think, behind the schedule, and we need to develop it because we might need it. I'm involved in a number of committees where majority of the colleagues are entirely against going for carbon capture and storage on basic principles. But many of them do say BECCS we have to develop because it's a kind of an insurance. It's another form of insurance in case we don't need the targets and it gets worse than we expected.
Okay, please.
Kjell Arleklet, Uppsala University and Texas University. Producing food for the population. A lot of the carbon dioxide emission and the use of fossil fuel is for food production. 30% or something like that. So I think that the most important thing for the future is to very soon change the habit of producing food, and that might be the best way to get down the carbon dioxide emission, because we need food and we have a global increase in the population, that if you don't change that, that will mathematically increase the carbon dioxide if you don't change that. So what's your opinion about future food production? Is that what we really should concentrate on instead of discussing other things?
Well, we really need to concentrate on a large variety of things. The food cycle is certainly very important, not purely from the production point of view, also the consumption point of view. I could say a lot about that, but I've decided to keep my mouth shut on that issue. because people tend to distort and misunderstand what I'm saying. But the entire food cycle, may I say, has enormous opportunities for bringing about efficiency improvements and reduction in emissions, not merely on the production side, also on the consumption side.
If I can just very briefly understand your sorry. If I understand your comments, the counter-argument would be, I take from a paper from my colleagues Pakala and Sokolov some years ago, the wedges of stabilization. The bottom line is that there's no single or two or three solutions. You have to do very many things. It's such a big challenge, energy efficiency, alternative energies, even nuclear energy. And so, but certainly, food by itself is a very big concern. So we agree with you that that's something that can take a lot of improvement. Yeah.
I do want to say something that maybe you didn't want to say on purpose. I mean, vegetarian diet is more efficient. There is no doubt about that.
But I'm glad Naki said it and not me.
but there is no doubt that we must improve the efficiency of food. Food is thrown away in affluent societies, while other people hunger. Yeah. And so we at YASA, and we are working now in an integrated way on the food, water, and energy nexus. In some ways, you cannot separate the issues. These are the three major problems, and they're all connected with each other. When we throw food, we throw water, and we throw energy as well.
Yeah. But climate change is one of the big threats for global
and genetic changes as well for the situation, of course.
I'll take two questions from our twittering listeners.
We received more questions actually on the Nobel Week Dialogue website below the stream. And one question coming from Renee Mortensen in Sweden is, considering that the world today is dependent on fossil fuels, including nuclear power to a degree of 85%, is it possible for energy sources such as solar and wind power to make a substantial contribution to lower carbon dioxide emissions to the nearest 10 to 20 years? Won't the production and transportation of these energy systems has to be based on fossil fuels?
Do you have another? Can you take another question as well, please?
Yes,
second
of course.
Question.
This is a question coming from Victor O. Ledenyov. And he wonders, how can we deliver the energy from the energy generation facilities to the energy consumers efficiently? Do you think that the application of the superconductors can help us to achieve this goal?
Okay, so two questions, one on the generation side and one on the transmission side, please.
Let me take the first question on wind and solar. We brought out a special report on renewable energy sources and climate change mitigation 2 years ago. And in that, we examined 164 different published scenarios of the role of renewable energy going up to the middle of the century and beyond. And interestingly, the range that we found in all these scenarios, which are well researched and therefore published, is that at the lower end, you get something like 11% of contribution from renewables in the middle of the century. At the upper end, you get 77%. Now, this clearly brings out the fact that how we are going to use renewable energy is dependent on the policies that we adopt today. And I think this is where we also need to develop a vision, because as has been said earlier, something that I've also mentioned, the Stone Age didn't end because we ran out of stones. The fact is that there are enormous benefits from moving to renewable sources of energy, energy access being one of them, other co-benefits, environmental and otherwise. And therefore, I think if we were to set visionary policies, then we would certainly be able to achieve a substantial amount of solar and wind utilization, as well as other sources of energy.
Thank you. Another question from the audience? Yes, please. Here.
My name is Christian Borg from representing Chalmers University here in Gothenburg. It seems like everything boils down to actually policy issues when you think about it. The technology is there, or potential is there. You have scientists willing to contribute. You have the facts on the table, more or less. What do you think is, from your own personal view, is the most difficult hurdles on the political arena to come forward, to move forward?
Great, that's my favorite question. We have talked about the science part, we have talked about technology, and now about the policy. And I would like to take this as the last question, because we unfortunately will have to move on, and this very fast 40 minutes have passed, and so this will be your last interventions, okay?
Okay, then I'll try to take a crack at it. I think that you asked what are the biggest challenges on policy, and my reaction to that, and it's a stylized, of course, in detail everything is more complicated, but my stylized reaction would be that the biggest problem is the volatility of policy, is that the decision makers, and I think in particular in the commercial sectors that do react very well to market signals, are really confused. It is difficult to make a position today because policies change from day to day. So I would say we talked about sustainability at the beginning. I think policies need to be sustainable too, as well. And so that people who make the decisions can also expect that the regulatory and other environments will be relatively stable. I think that will catalyze the investment that we need in the new systems. And in generally speaking, I think what we need to do to achieve the transformation, in particular in view of climate and sustainability, will require high investment. So this is also why we need stable policy frameworks, but also ones that are, of course, adaptive to the changing situation. You don't want to have a feed-in tariff for the renewables when they become mature and cheaper than the alternatives, but in that sense, stable.
Yeah, I think that one has to realize that different countries has different possibilities and opportunities. And for example, Sweden can solve its energy problem in many different ways without any emission of carbon dioxide at all. That is quite possible. But there are other nations, other parts of the world where the situation is much more complicated, and the demands of energy is not at all satisfied, and where the opportunities is different. So I think one has to really appreciate that some fundamental scientific progress will have to be made. It's not only a policy decision. It is, I would say, policy is a necessary condition, but not sufficient condition.
Molina?
Sure. Well, I do agree that policy is probably the main barrier as I see it now. And of course, we have to improve technology, we have to do all sorts of things. But to me, what happens is that the political leaders either don't have enough power themselves, as it's the case in the United States with President Obama, or are not yet convinced. The message has not come out sufficiently clear from our community that it's something pressing that needs an urgent solution. Part of the problem also has to do with the time scale. Politics is moved by the next election very often, and so it's going to be hard to get something done in just a few years. So you need leaders here. You really need statesmen. Historically, fortunately, there are good examples for that happening. And we have examples like the one with the stratospheric ozone layer I mentioned before, where things actually have happened. So I'm optimistic that in spite of that, the policy barriers will be met. But first, we have to convince enough policy actors that the problem is real. And as I mentioned before, one of the barriers that I see in the US is the US Congress at the moment just not believing the science. So that's the first step. You have to believe that there is a problem. And then, of course, you have to want to do something for society for the future.
Well, the one thing that we found in the fourth assessment report was the most effective policy instrument would be a price on carbon. And that, I think, will require political will, it will require public support. The other point that I'd like to make is that, there's also an enormous inertia in the system. We have to learn a few new things based on the knowledge that we have, but we also have to unlearn a few things. It's only then that we can move on.
Well, with that, I thank you all. Thank you, the panelists. Thank you all for coming here. Thank you, the listeners that are somewhere in the cyberspace, and invite everybody to join us in the final panel together with the others. Thank you very much.